Hello, in this tutorial we will work on radians and sectors using GeoGebra. The objective of this tutorial is to introduce you to the GeoGebra input bar and use of commands in the input bar through a lesson on radians. GeoGebra beginners, please refer to Introduction to GeoGebra and Angles and Triangles Basics on the spokentutorial.org website. In this tutorial, I worked on Ubuntu version 10.04 LTS and GeoGebra version 3.2.4. In this lesson, we will understand what a radian means and how to draw a radian, understand the relationship between the length of an arc and the angle it subtends, and complete an assignment to calculate the area of a sector. We will use the following tools in GeoGebra: circle with center and radius, circular arc with center between 2 points, and segment between 2 points. The drawing commands can be used in another way by typing commands in the input bar as well. In this GeoGebra window, now we will draw a circle of radius 5 units using the circle with center and radius. I click on circle with center and radius. I choose my center to be at the origin, radius 5 units. I will now plot 2 points B and C on the circle. Now we will complete an arc between these 2 points. I click on the circular arc with center between 2 points to draw an arc. I click on A, the center, B, and C. This completes the arc. Notice that the arc length is D equals 5.83 units. Now we will delete this arc and construct it another way. The arc can also be constructed by entering a command in the input bar here. This rectangular box here is the input bar. There are 3 drop down boxes next to the input bar. Here you can introduce some functions, define some parameters, and this is the command through which you can complete drawings on the GeoGebra window here. Now I will start typing arc here. You will notice that it completed the command for me. I can also look up this command from the drop down box here. I click on arc. You will notice that the command appears here with square brackets. If I click in the middle of the square brackets and hit enter, the syntax for this command will appear here. So the syntax that we will use for arc now is to define the circle and the 2 points. We'll have to define here the name of the circle and the 2 points between which we want the arc. From the algebra view, we can see that the circle is referred to as lowercase c, and the points between which we want to draw the arc are B, C, both in uppercase. So we will type the command here, arc C, B, C, and hit enter. GeoGebra is case sensitive. Now let's change the color and thickness of the arc that we have drawn from object properties here. We go to color. We define it as red. From style, we increase the thickness. Notice that the arc is now appearing as a bold red thick arc. Now we will draw 2 line segments AB and AC. We will again do this in 2 ways. We click on the segment between 2 points tool here and click on A and B. This completes the segment AB. We can also enter a command for the segment from the input bar. We will do segment A, C to complete the segment AC. Now we have completed the arc BC, drawn segments AB and AC and the sector BAC. We will now define the angle subtended at A by arc BC. We will call this angle alpha. We will choose it from the drop down box here. The angle command is angle B, comma A, comma C. We will follow the standard angle naming convention when we define angles in GeoGebra as well. We'll notice that the alpha value, the angle of alpha here subtended at the center, is 66.78 degrees. Now 1 radian is defined to be the angle subtended at the center when the length of the arc subtending the angle is equal to the radius of the circle. If we define the angle unit to be in radians by going to the options here and defining angle unit to be radians, we will find that the value of alpha now is 1.17 radian. We will now change the arc length to bring it closer to 1 radian. Notice that the arc length is d equals 5 units and the value of alpha, the angle subtended at the center, is 1 radian. We defined 1 radian. We also saw that this is the angle that will be subtended when the arc length is equal to the radius. What is the value of 1 radian in degrees? Now let's change the, I just zoomed it out a little bit. Now let's change the length of this arc to that of a semicircle. So the arc length is pi a, where a is the radius of the circle. Before that, I will redefine my angle unit to be degrees, because we want to find the value of 1 radian in degrees. We notice that when the arc length is pi a, that is a semicircle, the value of alpha is 180.21 degrees. And if I complete this circle, we'll notice that the value of alpha will be almost 360 degrees. So we notice from these two that the value of 1 radian will be 57.32 degree. Now we will understand the relation between arc length, radius and the angle subtended. For that we will define another parameter, another angle value theta in radian by dividing the value of alpha by 57.32. Notice that the value of theta is actually the value of the angle in radian. However, it appears with a degree symbol here because of a formatting difficulty. We will continue to use theta like this and not change the angle unit as radians, because we want to illustrate a formula using the arc length and the angle subtended. Due to a formatting difficulty, this formula can be explained only in this way. Now we will insert text in the GeoGebra window to introduce the formula that relates the arc length to the angle subtended. For an introduction on how to write text, please refer to the tutorial Angles and Triangles Basics. Now notice that when I change the arc length, you will notice that the value of theta changes and the relation between arc length and the angle subtended holds as d equals r theta, where d is the arc length, r is the radius of the circle, and theta is the angle subtended at the center in radian. Now we will look at an assignment to reinforce our understanding of what we have learned. Using what we have learned, show how the area of a sector will be area equals half into a square into theta, where a is the radius, theta is the angle subtended at the center in radian, and the formula is area equals half a square into theta. A small hint to complete this assignment is to compare the area of the sector to the quadrant. The assignment when drawn will look like this. We want to calculate the area of this sector here by comparing it with the quadrant here. I would like to acknowledge the spoken tutorial project, which is part of a Talk to a Teacher project supported by the National Mission on Education through ICT, MHRD, Government of India. More information can be found here. Thank you for joining me.